Hello student, welcome back to lecture series on discrete mathematics. We are in the continuation of syllabus from set theory and proposition. So guys, we have completed plenty of the lectures in our channel. So if you are interested to see similar videos, go and check in my playlist. In our today's video guys, we are going to continue one of the important example based on principle of inclusion and exclusion. Okay, so already in our previous lecture, I explained to you all principle of inclusion and exclusion, which is very much important for your final exam. Maybe you will get the probable chances for your end sem exam or in sem exam. Okay, yes, so I have taken one of the example based on principle of inclusion and exclusion. Okay, so without further ado, let's get dive into our example. First of all, I'm gonna explain to you all example and then we go for the detailed solution. Okay, so here in our example we have given in a class of every student, okay, is a major CS and math. That means we are having in a class two types of the student, one which is having branch computer science and another is having maths. Okay, and some students are there, they are having computer science as well as math. Okay, then the number of student having computer science as a major is 25. Okay, that means the number of student which goes to the computer science is a 25. The number of a student which having maths as a major is a 13. That means the student which are going for the maths, which is 13, and the number of student major in a both computer science and maths is a 8. That means the student which are in a computer science as well as the student which are in a maths, which is a 8. Okay, that means we have intersection. Whenever you get the and word, that means you have get the intersection, then the how many student in the class. Okay, so we have given this much data and using this one we have to find out how many students are present into our class. Okay, yes, first of all, find out what we have given. First of all, we have to explain what it is given here in our example. Okay, so write down the data which is given to us. So here as per the given data, what we have, number of a student which is a major in a computer science. Okay, how many students, which is a 25. Okay, that means I call this event as A. So cardinality of event A is a 25. Okay, again number of a student which is a major in a maths. Okay, now we have taken for the CS, now which is major in a maths is a 13. Okay, so I am calling this event as a B. So cardinality of a set B is a 13. Okay, and later on what we have given, the number of students major in both computer science and maths. Okay, which is 8. Okay, that means both are common in math and as well as CS. Okay, and word is there, that means intersection. So cardinality of A intersection B is a 8. Okay, cardinality of A intersection B, which is a 8 over here. Okay, yes, so and what we want, our claim is here. What we have claim, let me write the claim over here. We have claim how many students are present in the class. Okay, number of students present into the class, number of students presents into the class. Okay, that means we want everything, that means how much total entirely student present into the class. That means we want, in mathematical language, we want the cardinality of A union B. Okay, so what we have here, total learned from math as well as CS. Okay, so A means CS and B means math. That means we want the total student into the our class, which is a cardinality of A union B. Okay, that one we want. Okay, yes, this is the total student we want, means union. That means the student which is say in A as well as which is in a B. Okay, that is the cardinality we needed here. Yes, so for finding the cardinality of A union B, we know that by inclusion and exclusion principle. By inclusion and exclusion. Okay, So we by using inclusion and exclusion principle, we want the total amount of student from the class. Okay, so what the inclusion and exclusion principle says that inclusion and exclusion principle say that coordinate of A union B can be written as coordinate of A plus coordinate of B minus coordinate of A intersection B. Okay, this is the principle for inclusion and exclusion. Okay, yes. Now what is the remain here? Need to replace the value. So we know that coordinate of a set A is 25, coordinate of a set B is 13, and their intersection is 8. Okay, so replace the all values here. Coordinate of A 25 plus coordinate of B is 13 minus coordinate of A intersection B is 8. Okay, okay, so find out their addition and subtraction. Okay, then 25 plus 13 minus 8, so we get the totals A union B is 30. Okay, that means then the number of students present into the class is 30. Okay, so this is our required answer. See guys, how the answer which is easy here. Okay, such a type of the questions you will get in your question paper for your in-same and end-same questions. Okay, so I hope you all have understood everything here guys. Don't have anything difficult. This is the question for 3 marks, so if you want you can note it down the question. Okay, so it is a very short question and short answer, but the similar type of the question we have probable chances for your in-same and end-same exam. Okay, so I hope you all have understood. Might be if anything difficult for you all guys, let me know in my comment section. I will come up with the similar videos. So that's it for our today's lecture. Thank you everyone. Thank you for my today's lecture.